In the sport of bungee jumping, people stand on a high platform and allow themselves to fall while tied onto the platform by an elastic cord attached to the ankles. So this is the platform from where you are jumping over here. Okay, so I hope you would have learned, you have seen the bungee jumping here. Otherwise, I would like to put a video over here. Let us see this. If I get a suitable video, I'll just put it across. Okay, Johanna does a bungee jump. The unstretched length of the bungee jump is 25 meters. This is 25 meters. As you jump over here, so the unstretched cord is essentially stretching over here. The figure shows three important positions during her motion. In her initial drop, the lower point she reaches is with her feet 45 meters below the platform. So she is what here, and this is the maximum height which she drops down, maximum depth from the platform. Okay, and then as Johanna drops, in describe the energy changes that takes place. Do this by completing the table below by writing increasing, decreasing, or constant. You should use only these three terms. Under the headings gravitational potential energy, kinetic energy, and elastic potential energy, the top row refers to the energy changes between the initial position on the platform, initial position platform 2A. Okay, fine. And the point where the bungee jump cord starts to stretch, middle row as she falls. Okay, all these are given over here. Let us read this. Now, what does it say? Gravitational potential energy from platform to A. I will write down the figure briefly. So this is the platform here, and this is my point A here. Point A here, and then what is this point A? Let us go through this. Point A, cord begins to stretch here, which means no stretching. Until here, no stretching. No stretching. Okay, and then what is the height here? Height here is 25 meters. Height here is 25 meters. And from point A to point B, point A to point B, what is happening there? 45 meters. So final equilibrium position is at point B. Final equilibrium position, which means what? Final equilibrium position here, this is at some height. That height is not given. This is 45 meters given. This is not given here. Final equilibrium position, which means what? So there is a stretching being seen, some value of x. We do not know what is this. So here you can say Hooke's law would be applicable. F is equal to kx. Slowly, as the displacement is increasing, the rubber cord that you have will also have a restoring force F proportional to x. Okay, and after this, because of her weight, she comes to a point C. When she comes to point C, is the lowest point of descent, and this is the point where she is now hanging over here. She is now hanging over here. Okay, so which means that at this point C, her weight, okay, makes her to come all the way along until here. So the rubber cord which you have put over here is being stitched, and this total height is seen to be 45 meters, which means starting from point A to point C, this is another 20 meters. Okay, sometimes we need to write down all the hidden values, then only you will be getting this. Okay, with this we will now start answering. So from platform to A, what is happening to the gravitational potential energy? So now when from platform to A, so where is this? This is the platform. See, ground is somewhere over here. From here to platform, what's happening? The height is much higher, right? So therefore, so at this point, the potential energy was the maximum here. A person, when he was standing at this point on the platform, it was maximum. But when she jumps downwards, what's happening? The height is reducing. And when the height is reducing, potential energy should also decrease. So therefore, this should decrease. From A to B, once again decrease only. From B to C, once again decrease only. Why decrease? Because you see, this height should be counted from the ground over here, right? From here to here, it was maximum height. Here to here, reduces. Here it is reducing, still reducing over here, right? So therefore, so you see the height is reducing, potential energy decreases. First part is done. Then kinetic energy. Now what happens to the kinetic energy? From platform to A. From platform to A, what happens? The kinetic energy keeps on increasing because here she was at rest. But when she fell down here, the velocity was higher. And when she started from point A to point B, what happened? There was a stretching over here, but still she was increasing the kinetic energy. The velocity was increasing. Velocity was increasing, right? And then what happens? From B to C. After B to C, it has come to an equilibrium position here. After this, still she went downwards, but what happened? So there was a pulling being seen here. Okay, this is nothing but your springs in your SHM. Okay, so initially when you have the object kept over here, the object now pulls this one, so the object comes forward. See, this is the way how it looks like, right? This is just spring over here, this is the object over here. So at the equilibrium position, the spring goes to the maximum extension here. At the equilibrium position, the velocity is maximum. And beyond this, if it goes, what happens? The velocity reduces. Why? The restoring force here now tries to pull it in the opposite direction. So therefore, it's pulling in the opposite direction. She starts slowing down, and when she reaches here, what happens? The velocity becomes 0 over here. So she gets suspended there itself, right? So therefore, here it is decreasing. From B to C, it decreases. Okay, you can also say it slows down and decreases. Slows down, decreases. Now, elastic potential energy. What is the elastic potential energy? Elasticity doesn't come into play at all because it's just moving with a free fall over there, right? So therefore, here it is constant. It's constant over here, and or maybe you can say there's 0 over here. There's no elastic potential energy. From A to B, what is happening to A to B? In A to B, it is seen to be increasing. Why increasing? Because you know there's an elastic limit over here, and the extension, elastic potential energy depends upon the extension. What is the formula for it? Formula for it is given by E is equal to half kx square, right? So therefore, there is an extension being seen. So if at all, if you did not apply any load, where will the cord stand to? The cord will stand only until here at a height of 25 meters. Because it fell down from here, and because on the weight of the cord and also to the weight of the person, it started moving like this. But it did not stop here, okay? It started to extend and it went until here, okay? Then the weight of the person along with the inertia increased it to this point over here. But by the time, it also started to pull it upwards. Okay, so elastic potential energy is increasing over here. Now what's happening over here? So here also elastic potential energy is increasing. Why do we say increasing here also? Because elastic potential energy is dependent on the extension. Extension is seen here, extension is seen here. This is your natural length, right? This is your natural length. So therefore, so both the places extension is seen, and this elastic potential energy keeps on increasing over here. So all these terms are very important to write. You need to write appropriately. Only then you will get how much? 5 marks over here. Okay, now let us move on to the next one. Take Johanna's center of mass to be about 1 meter above her feet when she is standing, and her mass to be 54 kg. Mass is given. Assume the Bungee cord as an elastic constant. K is given. Estimate Johanna's vertical speed at point A. At point A. Where is point A? Point A is at this point. What's happening at point A? It's free fall. Whether you are being tied with the Bungee cord or not, okay, it's a free fall that's happening. So here to here it is 25 meters. Since the center of mass is at this point, you should take 1 more meter here, right? The total distance from with respect to center of mass is seen to be 26 meters. Okay, now let us look what does it say. Estimate Johanna's vertical speed at point A. What should you do? Simple question. Okay, so she starts from, you take a particle from here, from the platform, drop it here. When it reaches the point A, along with 1 meter, because it's an extended object, no? So total distance here, this distance is 25. Total distance from here to here should be 26 meters. He is asking you what is the velocity here. What is the velocity here? 0. What should you use? Kinematics, because earth, right? There's a gravity. So therefore, v square is equal to u square plus 2as is the formula you are going to use. So u, what is u? 0, because you just dropped, right? U is equal to 0 plus 2 into, what's the value of A? A is minus g, right? And S value, what is S value? 26 meters, plus or minus, it's also minus 26. Why minus 26? Because this is your positive x-axis, this is your positive y-axis, and anything that comes downwards is negative, right? So therefore, this should be negative, and this is less. You get 2 into minus becomes plus 2 into g, 10 into 26. 10 into 26 is 260, multiplied by 2 is 520. 520, and thus your value of v should be square root of 520. Okay, let us find out what is this value. Where is it? It's here. Square root of 520. 520 square root will be 22.8. Okay, so answer is 22.8 meter per second. 22.8 meter per second. Did we get it? Yes, or 22 to 23 meters per second is the right answer. Okay, calculate the resultant force acting on Johanna when she is at C, lowest point of a drop. When she is at C, where is the point C? At the point C. What is the question over here? Calculate the resultant force. Resultant force. What will be the resultant force acting on Johanna when she is at point C? Resultant force at point C. This is the cord at point C here. And what is the force acting downwards on Johanna? Which is nothing but mg. And there is a tension acting here, right? So what's the value of tension? Tension should now be, is nothing but pulling force, which should be equal to k times x. So what is k here? K is already given. Where is k? K value is 75. 75 here. And what is the x here? X is nothing but the extension. From where to here? From here. This is the natural length of the rubber cord. And from here to here is your final length, right? So this should be 20 meters over here. So what you do is, you take x equal to 20, k should be, what's the value of k? K is, or just take the value of k. K value is 75. So 75 multiplied by 20 should be your answer. So this is your tension now. How much is the value? Some value you get. The resultant, what is F resultant? F resultant should be T minus mg, which should be 75 into 20 minus 54 kg multiplied by 10. So how much will this be? Let us calculate this value. So you get 75 star 20 minus 540, which will be 960. So 960 unit is Newton. Thus the answer should be 960 Newton. Okay. Then after reaching the lowest point, the stretched bungee cord accelerates Johanna upwards. In this way, she bounces up and down a few times more, stopping hanging by her ankles at the end of the cord. By how much does the cord change when she is in the final position? What is the maximum elongation that the cord is being seen? That's the question that we need to answer. When the card is stretched in the final position, okay, so what we do is, let us draw the card. This is the way how it is now in the final position. So now we know that the force acting here is mg, and this is nothing but k times delta x. At equilibrium, these two should be equal, which means that k times delta x should be equal to m into g. And what do we need? We need the value of delta x. Delta x should be equal to mg by k. M is 54, g is 10, and k is 75. Okay, let me use all this to get the value of, where is it? It's here. Okay. So 54 star 10 divided by 75 should be 7.2. 7.2, what is the unit? Meters. So the cord has stretched to a maximum distance of 7.2 meters. Okay, so with this we have come to an end to today's, that is this week's, all the classes. Okay, let me stop. Thank you. Before leaving this video, do share, like, comment, and if you have any questions, you can always put me in the comment box. I would like to make a separate video on this. And if I am very fast, slow, whatever it is, do mention me so that I can improve on it myself. And do subscribe to my channel finally, so that more number of viewers will be there, and it's also a great encouragement for me. Of course, it has been an encouragement for the past for many days. The reason is because, you see, I started somewhere in the month of September 5th, I think I started. Now we are towards the end of September. Nearly 100 to 120 subscribers have been increased, and nearly 1000 videos have been uploaded so far. Okay, so though it's a bit slower, but still, okay, so it is constantly rising. Let me try to help you out as what best can be done. Okay, thank you once again.